industrial heat goes electric with thermal battery tech. Fossil fuels have long dominated industrial process heat, particularly in sectors that depend on extremely high temperatures, cement, steel, and glass among them. Electrifying those processes has remained a tough technical and economic challenge, but Boston-based Electrified Thermal Solutions is moving to change that, commissioning its first commercial-scale thermal battery at the Southwest Research Institute, SWRI, in San Antonio, Texas. Their Joule Hive system can store 20 megawatt-hours of energy and deliver temperatures up to 1,800 degrees Celsius, previously achievable only through direct combustion. Unlike traditional electric heaters, this system stores heat using conductive fire bricks and releases it as hot gas on demand, aligning thermal output with production schedules. The battery charges using grid electricity, specifically medium-voltage 13.2 kV AC lines, commonly found at industrial facilities. By charging during periods of low or negative electricity pricing and discharging as needed, the system provides a new way for manufacturers to access high-temperature heat while managing energy costs more flexibly. Electrified Thermal's approach removes some of the typical barriers to industrial electrification. Because it doesn't require extensive electrical infrastructure like step-down transformers or high-maintenance components, the system reduces complexity and installation costs. Its modular format supports 1 to 5 megawatt heat demands per unit and can scale up for larger facilities by adding more modules. Thermal storage as a strategic energy lever. High-temperature industrial heat is responsible for nearly 1/5 of global energy consumption, with roughly 90% of that demand still met by fossil fuels. While sectors like transportation and building heat are rapidly electrifying, industrial heat has lagged due to high cost, technical limitations, and perceived risk. The Joule Hive is engineered to address those friction points. Its core component, fire bricks developed at MIT, are conductive, durable, and designed for decades of daily thermal cycling. Electrified Thermal reports a service life of more than 20 years for the system, aligning with the capital planning cycles of heavy industry. Beyond its decarbonization potential, the company pitches the technology as an operational hedge, because it enables facilities to separate when they buy electricity from when they need heat. It offers a buffer against market volatility and fuel price spikes. That dynamic could prove valuable to cost-sensitive industries like steelmaking, cement production, and chemical processing, where margins are tight and emissions are high. Following the successful SWRI installation, Electrified Thermal is advancing toward broader deployment, with support from industrial stakeholders such as Holcim, Vale, and ArcelorMittal. The company has secured early customer interest and aims to bring 2 gigawatts of thermal capacity online by 2030. Commercial installations with manufacturing partners are slated to begin in 2026. If the systems perform reliably at scale, they may help redefine thermal energy as a flexible, low-carbon input rather than a fossil fuel necessity.